Okay, lesson 101 continued. Video 2. How do you spell continued? Does that look right?
Yeah.
Okay. So.
You gotta put a dot on your I. So it's not continue.
Good. Okay.
Good
job, Spencer.
What? We're talking about continue. That's not a word.
Okay, end behavior. This is an example. If f of x equals x squared plus 3x to the 4th minus 5x to the 7th plus 7. So we're going to talk about this. The leading coefficient is negative 5. The degree is 7. So it's an odd function with a less than 0. Okay, so it's odd, a less than 0. So we can look at our chart. As x goes to negative infinity, f of x is going to go to positive infinity. So we know the end behavior is going to be going up this way and down on the right. And that's just kind of example that you can see what it would look like. Tan? Oh, you were doing the...
Oh, yeah, no, how do you know? It's because this is a negative slope. Right. And this is a positive slope. I just think of like progress, like a money.
Like this.
Like, oh, you're more money.
Yeah.
That's negative.
Negative. Going down, positive.
No, I'm serious. That's positive. Okay.
Pretty good.
So here's the steps we're following. These are the steps you want to take. Number 1, identify the real zeros. This is for graphing. I'm assuming that's what it is. Number 2, make a table of ordered pairs. This is the step that kids want to skip, that they think they don't need to do. Very important. Include, these are the points you have to have. The x-intercepts that you found, the x values that lie between the x-intercepts, and the y-intercept. Number 3, plot all the points that you just found. Number 4, determine the end behavior. So all of that on the page previous is step 4. And then step 5, you can kind of sketch the graph. I don't have an example for you right now on this one, because I need to continue to go about like turning point behavior. So when you have a turning point, that's where there's like called a local min or a local maximum. So if, I'm going to try to say this without writing it all out. They actually have it written on page 709. But if you have a hump that's up, you have a local maximum. It's called a local maximum. If the hump is down below, that's called a local minimum. So on this one right here, these are called local maximums, and these are called local minimums. And they say it in real fancy ways, like if the interval around this, so in other words, it's increasing before and then decreasing after, then it's a local maximum. So they kind of use some fancy language, and if the, yeah. So if you were to look around that point, every all like right around it, all the points will be f of those points will be less than that local max. So duh, that's because it's the highest point. So anyway, okay. For every polynomial of degree n. Okay, so whatever degree you're looking at, there are at most n x-intercepts. And I feel like we've talked about this before. Like if it's a cubic, you're going to have at most 3 x-intercepts. You can't have any more than that. And at most n minus 1 turning points. So if you've noticed on our graphs on the previous page, I drew them all with the maximum turning points, not necessarily the maximum x-intercepts, but I did try to put in, like for the 5th power of 5, I did 4 turns, because that's the most you could have. Okay, that's the end of part 2 for reals.